Hi guys, it's Jeremy from the chemistry and I'm excited once again to bring you guys another video. What up, Chem fam? Listen, we're going to be continuing our talk on atomic radius and the changes with respect to how you go across the periodic table of elements. Now, last video, we talked about how the atomic radius changes as you go down a group. Now, we're going to be talking about the changes that occur as you go across a period. Now, we said that going down a group, the atomic radius increases. Anybody want to hazard a guess as to what happens to the size of the atoms as we go from left to right across a period, any period, in the periodic table of elements? Y'all thought I was joking? Yo, $50, bring the money straight. Let me go, guys. Bets coming, bets coming. Does it increase or does it decrease as you go across a period? Let's examine some elements from period 3, and this will go for all the atoms across any period. We have sodium on the left, silicon in the middle, and chlorine to the far right of period 3. You can see from my diagram exactly what happens to the atomic radius as you go from left to right across period 3. Sodium on the far left has the biggest atomic radius. Silicon in the middle gets smaller, and then chlorine on the far right gets even smaller. We said and recall from our last video that the two main factors that influence the atomic radius of any atom are 1, the number of inner shielding electrons, and 2, the amount of protons inside of the nucleus. Now let's do some calculations and see exactly what's going on here. Okay, first, let's talk inner shielding electrons as we go across the group. And you'll notice something very intriguing here. In sodium, in silicon, and in chlorine, the number of inner shielding electrons is 10 in sodium. In silicon, it's 10. And in chlorine, it's still 10. Remember, the way how we define inner shielding electrons are all the electrons which are not found in the valence shell. And because they're in the same period, they all have the same number of inner shielding electrons. And remember, inner shielding electrons do the job of basically cutting down the effect that the valence shell electrons feel from the nucleus. However, as you go across the period, the number of inner shielding electrons remains the same. At the same time as you're going across a period, you're also going to be increasing the number of protons. Sodium has 11 protons. Silicon, as you go to the right, has 14 protons. And chlorine on the far right has 17 protons. Now remember, we said you can always calculate the net pull that the valence shell electrons are going to feel. And you can do that by taking the amount of protons and subtracting the amount of electrons or inner shielding electrons. And the reason for that is because each proton has a positive charge while each electron has a negative charge. And you'll notice as you go from left to right, 11p minus 10 electrons for sodium, you have a feel of +1 or a pull of +1. For silicon, you have 14 protons, subtract 10 electrons, you have a pull of +4. And for chlorine, you have 17 protons minus 10 inner shielding electrons, giving you +7. Now, as you go across that period, you go from +1 to +4 to +7. You can see the gradual increase as you go from left to right across the period in what the valence shell electrons will be feeling. Now, let's put a nice little bow on this thing. You are not increasing the amount of inner shielding electrons. They remain the same. However, the pull that the valence shell electrons are feeling from the nucleus is increasing as you go from left to right. Therefore, with the same effect, with the nucleus's pull being cut down by the same way, but the pull of the nucleus increasing every time you go from left to right, what's going to happen is as you are on the left of any period, you're going to have your largest atomic radius. Then you go to the middle, and the nucleus is able to pull that valence shell in just a little bit more because there are more protons there, but the same number of inner shielding electrons. Then you have on the far right where you will go, where the valence shell electrons will even be pulled in even closer. And that's the reason why as you go from left to right across any period, your atomic radii decreases. What's good, Chem Fam? Listen, guys, I am working to make sure that I have all of your CXC and CAPE needs on YouTube, Instagram, Facebook, and Twitter. Just follow at the chemistry. Yeah? Go do that now.